Welcome back, y'all. We are continuing 6.8 standard reference and coterminal angles in radians. So example 5 is where we left off, and this has quite a few instructions in it. It wants us to find a coterminal angle, if we need it, between 0 and 2 pi. And it wants us to find out which quadrant or on which axis it lies. Then draw the triangle and find the reference angle. So we're putting all of this together. Okay, so let's take a look at 7 pi over 4. That's really what I wanted to do. Let's take a look at 7 pi over 4. We want to number this axis in terms of pi over 4. So 0 is always on the right. Pi is always on the left. This is a denominator of 4. So we're going to number 4 pi over 4. And then half of that for up top is 2 pi over 4. That means we're counting by 2 in the numerator. 2, 4, 6 pi over 4. And then to 8 pi over 4. And I'm going to move that up for reasons which will become apparent in just a second. So 7 pi over 4 would start at 0 and wrap around to between 6 and 8 pi over 4. So here is 7 pi over 4. Since that's already between 0 and 2 pi, that is 7 pi over 4. And we want to find the reference angle. Reference angle always goes to the x-axis. So our reference angle will always go from where we end to the x-axis. That reference angle is going to be pi over 4. It's from 7 pi over 4 to 8 pi over 4. It's 1 pi over 4. So there's your standard and reference angles here. Now, let's take a look at B. B is 11 pi over 6. If we look at this one's the quadrant as well. There's not a spot for that, but that's okay. This angle is in quadrant 4. So now let's look at B. 11 pi over 6, that is between 0 and 2 pi, so that will be the standard angle, 11 pi over 6. Label this axis with pi over 6, 0, 6 pi over 6 on the left. Half of that is 3, so 3 pi over 6 to 6 pi over 6, 9 pi over 6, and around to 12 pi over 6. 11 pi over 6 would be between 9 and 12 pi over 6, closer to the 12. So we'll start at 0, wrap around to 11 pi over 6. And that reference angle is always to the x-axis. That reference angle is pi over 6. And this is in, again, quadrant 4. Remember, again, reference angles, whatever the denominator is, pi over that denominator is going to be your reference angle. So let's take a look at C. 5 pi over 2. 5 over 2 is bigger than 2, so we will need to subtract the equivalent of 2 pi. We need to use the denominator of 2, so that will be 4 pi over 2, because that reduces to 2 pi. So this angle is coterminal to pi over 2. Okay, pi over 2 is going to be that standard angle between 0 and 2 pi. Labeling the circle, labeling the axis with the denominator of 2, 0 on the right, 2 pi over 2 on the left. So 1 pi over 2 on the top, 3 pi over 2 on the bottom. Start at 0. Pi over 2 is straight up to pi over 2. So that reference angle is from 0 to pi over 2, which is simply pi over 2. Again, pi over 2 is almost in quadrant 1. It's not in a quadrant. It's on the x-axis. So we don't call it in a quadrant, but it is on the x-axis. So let's look at D. We have a negative angle, so we know automatically we're going to have to adjust it. We need to add pi over 2. So with a denominator of 6, that's going to be 12 pi over 6. That means our angle is coterminal with 7 pi over 6. 7 pi over 6 is between 0 and 2 pi, 0 and 2 pi. So that will be our standard angle, 7 pi over 6. Labeling this axis, zeros on the right, pi on the left. I'm going to label that as 6 pi over 6. That makes the top half of that 3 pi over 6, which means we count the numerator by 3. 3 to 6 to 9 pi over 6 and 12 pi over 6. Then our angle, 7 pi over 6, would start at 0. 7 is between the 6 and the 9, a little closer to the 6. So 7 pi over 6 would be here. That would be our standard angle. Then the reference angle is always to the x-axis. And that angle is pi over 6. Again, we have a denominator of 6, so pi over 6 is automatically our reference angle, and this angle does terminate in quadrant 3. Now, let's look at E. Again, we have another negative angle, so we'll need to add to it. We have a 6, so with a denominator of 6, to add 2 pi, the full radians all the way around the circle, we'll add 12 pi over 6, so that angle is 11 pi over 6. That is between 0 and 2 pi. So 11 pi over 6 will be our angle. Labeling the axis, 0 on the right, 6 pi over 6 on the left. Half of that is 3. 3 pi over 6 to 6 pi over 6. Bottom would be 9 pi over 6. And right is 12 pi over 6. 11 pi over 6 would start at 0. It's going to wrap all the way around to 11, which is between the 9 and the 12, closer to the 12. So this is where 11 pi over 6 would fall. That would be our standard angle all the way around. Okay, so that does land in quadrant 4. Put that in the right order. It does land in quadrant 4. Reference angle always goes to the x-axis. So our reference angle is in between here, and that is pi over 6. From 11 pi over 6 to 12 pi over 6 is a difference of pi over 6. And let's look at F. 13 pi over 3. 13 over 3 is bigger than 2 pi, so we will need to subtract. So we'll subtract over 3 with common denominator. That's going to be 6 pi over 3, and that will give us 7 pi over 3. 7 pi over 3 is still too big, still bigger than 2, 7 over 3. So we'll subtract another 6 pi over 3. And we get pi over 3. So our standard angle will be equivalent to pi over 3. And labeling this axis in terms of pi over 3, we have 0 on the right. We have 3 pi over 3 on the left. Up top is going to be half of that, 1.5 pi over 3. So we count by 1.5 in the numerator, 0, 1.5, 3, 4.5 pi over 3, and 6 pi over 3. So our standard angle would start at 0. Pi over 3 is a little, in quadrant 1, it's a little closer to 1.5. So pi over 3 would be here. That does fall in quadrant 1. Wanted to box that. And then the reference angle always goes to the x-axis. So our reference angle is here. Okay, from 0 to pi over 3 is a reference angle of pi over 3. And again, you can use the denominator in radians to find that reference angle. So a few more examples on the top of the next page. Let's look at G. We have 5 pi over 2 which is the same as example C. So we're not going to do this one again. But let's go to H. Negative 2 pi. Negative 2 pi, we could graph on the circle, labeling negative, but we want that standard angle that's between 0 and 2 pi. So we need to add 2 pi. There's no denominator here, so we just add that 2 pi, and that is equal to 0. So our standard angle is 0 radians, 0's on the right, pi on the left. That puts pi over 2 on top, and 3 pi over 2 on the bottom. 0 is simply at 0. And that reference angle to the x-axis is 0. We are on the x-axis. So instead of a quadrant, we say that we are on the x-axis, and that reference angle is 0 because we did not move from said x-axis. Let's look at I. 7 pi is bigger than 2 pi, so we need to subtract 2 pi until we get something that is between 0 and 2 pi. So that gives us 5 pi. That's still bigger than 2 pi. So we'll subtract again, and that gives us 3 pi, which one more time is still too big. So we'll subtract 2 pi, and that gives us pi. Okay. As long as you're subtracting a multiple of 2 pi, you can jump straight to subtracting 6 pi. If you see that quickly, don't worry about it. 0's on the right. Pi is on the left. That puts pi over 2 on top and 3 pi over 2 on the bottom. Pi is to the left. Here is our angle. We start at 0. We do have a vertex. It does make a straight angle, but we do have a vertex there. And that standard angle is pi, between 0 and 2 pi. We are on the x-axis. So that reference angle to the x-axis is 0 because, again, we are sitting on the x-axis. Now, one other piece we want to look at in this lesson is converting between radians and degrees. So from the very beginning of this lesson, we learned that 2 pi radians is equivalent to 360 degrees. So that meant that pi radians is equal to 180 degrees. Well, with that fact, 180 over pi is equal to 1. So is pi over 180. So to convert between them, we multiply by that ratio, either 180 over pi or pi over 180. Okay? Now, to figure out which one we need, okay, look at what you're given. In example 6, we're given radians. We're asked to convert into degrees. So the final answer needs to be in degrees. So we need the degree on top. The other thing we need is we need the pi's to divide out because degrees doesn't typically use pi's. So that means we need to multiply by, we need the 180 degrees on top because that's the unit we want in the end, over pi because we want the pi's to divide out. Okay, now the pi's do divide each other out, and I recommend you do this because we are doing these without a calculator. Take 180, divide it by 3. 180 divided by 3 is 60. 18 divided by 3 is 6. Tack a 0 on it. Then 2 times 60 is 120 degrees. And that is your degree measure. problem. Now, for part B, again, we have radian measure. We want degrees. So what we want, the unit we want needs to be on top. So multiply by 180 over pi. That will, again, divide out the pi's, which is what we want. Okay, again, divide 180 by this denominator. 180 divided by 6 is 30. 18 divided by 6 is 3. It's going to be 30. And so what we need to do then is multiply 15 by 30. Well, 15 times 3 is 45. Tack on a 0. And this negative stays, and that is negative 450 degrees. The problem didn't ask us to convert it to a standard angle from 0 to 2 pi, so we'll just leave it in this form. Now, converting degree measures into radians, we do a very similar thing. Consider this over 1. Degrees are on top. We need the degree measure to divide out, so we need 180 on the bottom. We want radian measure in our final answer, so pi is on top, okay? And what we need to do here is reduce that fraction to 25 over 180. First thing I notice is that we can divide both of those by 5. They end in a 5 and a 0. They both divide by 5. 225 divided by 5 is 45. And 180 divided by 5 is 36. Now, looking at these numbers, we can divide both of these by 9. So 45 divided by 9 is 5. 36 divided by 9 is 4. And that won't simplify any further. So this answer is 5 pi over 4. Typically, you won't have to reduce something that crazy. It could happen, though. Now, let's look at B. Negative 600. Think of that as over 1. We need to multiply that by. We want radians in the final answer, so pi goes on top. 180 degrees goes on the bottom. So we need to reduce the fraction 600 over 180. First thing I'm going to do is divide that by 10. So I'm going to work with 60 over 18. Okay, can divide both of those by 6. And that gives us 10 over 3, which won't reduce any further. So there was a negative sign, so this answer is negative 10 over 3, and there is a pi. So 10 pi over 3 is that radian measure. And that is how you convert between degrees and radians. Now, one other little tidbit that may help you, okay, since pi radians is equal to 180 degrees, to convert radian to degree, you can sub 180 degrees for pi and simplify. Pi is 180 degrees, so to convert, you can replace pi with 180 and simplify. Now, that only works if you already have a pi in the problem. That's why I taught you the ratio multiplying first. Okay. All right, guys, that's it on 6.8, standard reference and coterminal angles in radians. We will do exact values with radians in our next lesson.